Cauchy's mean value theorem. Let's look at the statement. If two functions f of x and g of x are such that both are continuous in the closed interval ab, both are differentiable in the open interval ab, and the derivative of g is not equal to 0 anywhere in the open interval ab. If these three conditions are satisfied, then there exists at least one point. That means there can be more than one point, but at least there will be one point, let's say C, belonging to the open interval a comma b, such that f of b minus f of a divided by g of b minus g of a is equal to the f prime of c by g prime of c. So remember, this is the ratio of the increments between 2 points, and this is the ratio of the derivatives. And also remember that f of b minus f of a by b minus a is equal to f prime of c. This is nothing but Lagrange mean value theorem, right? So in a way, here these were the points b and a, the end points. Now here we are talking of not of b and a, but we are talking of the result of a function g of b and g of a. So which means basically that this Cauchy's mean value theorem is a more generalized version of, or more general version of Lagrange mean value theorem. So let's see how to prove it. Let lambda is equal to f of b minus f of a divided by g of b minus g of a, and here the denominator is not equal to 0. G of b minus g of a is not equal to 0. Again, if g of b minus g of a is equal to 0, then g prime of x is equal to 0 in the open interval ab, which is against the third condition, and this is based on Rolle's theorem, and this is the third condition of Cauchy's mean value theorem, that g prime of x is not equal to 0. Let's have an auxiliary function. Capital F of x is equal to f of x plus lambda g of x. Now here we will choose lambda such that f of a is equal to f of b. So when we do that, what happens? F of a plus lambda g of a is equal to f of b plus lambda g of b. Let's rearrange this. Let's say lambda g of a minus lambda g of b, f of b minus f of a. Now here lambda is common, so g of a minus g of b is equal to f of b minus f of a. Okay, so lambda is equal to f of b minus f of a divided by g of a minus g of b. But we want the denominator also as g of b minus g of a. So let's reverse that. So basically what we are doing is we are changing the signs of these two, right? So this becomes minus, this becomes plus, and now we can write g of b minus g of a. But since we have changed the signs, we need to make sure that it is neutralized by putting a minus sign in front. So lambda is this. Now let's substitute it back into this auxiliary function. So capital F of x is equal to, remember this is f of x plus lambda g of x. So f of x plus lambda is what? Minus this. So let's make this minus f of b minus f of a divided by g of b minus g of a times g of x. Now here f of x is continuous, f of x is differentiable, again based on in the closed interval ab, and this differentiable in the open interval ab. That is because both f of x and g of x are continuous and differentiable as well. Now f of a is equal to f of b. Why? Because we have chosen it like that. We have chosen lambda such that f of a is equal to f of b. So basically 1, 2, 3 conditions of Rolle's theorem, mean value theorem, is satisfied. So based on the Rolle's theorem, we can say there exists C belonging to the open interval AB such that f prime of C is equal to 0. Okay, if the derivative of the auxiliary function at C is equal to 0, it means f prime of C minus f of b minus f of a divided by g of b minus g of a times g prime of c is equal to 0, which implies f prime of c is equal to f of b minus f of a by g of b minus g of a, and this g of c, g prime of c, that would come to this side, g prime of c. So which is what the Cauchy's mean value theorem says. So here the important point is that we are creating a new auxiliary function which basically relates these two functions which is given to us. Yes. Okay, let's solve one or two problems to see how this gets applied. Now let's say f of x is equal to log x and g of x is equal to 1 by x, both in the closed interval 1 comma e. Now f of x is equal to log x, so f prime of x is equal to 1 by x, g of x is equal to 1 by x, so g prime of x is equal to minus 1 by x squared. Now both f of x and g of x are continuous, be careful, in the closed interval 1 comma e. We can't say that f of x itself is continuous, or g of x is continuous. What we are focusing on is the interval 1 comma e. In that interval it is continuous. Similarly, f of x and g of x are both differentiable in the open interval 1 comma e, and we know that g prime of x is not equal to 0 in the interval 1 comma e. So all the three conditions are satisfied. So as per Cauchy's mean value theorem, f prime of c by g prime of c is equal to f of e minus f of 1 by g of e minus g of 1. Now f prime of c is what? F prime of c is going to be 1 by c. So 1 by c divided by g of c is what? Minus 1 by x square divided by minus 1 by, we are talking at c, so c square is equal to f of e would be what? F is log, so log of e minus log of 1 divided by g is 1 by x, so 1 by e minus 1 by 1. Okay, now we can say c, 1 by c times minus c square, this and this gets cancelled, log of e is 1. Here remember, in higher mathematics, log and natural log, when we say log, we invariably mean natural log. There are some branches of science where if we want to say natural log, we have to say ln, but otherwise take it as the same. Okay, so when we write log, assume that we are talking of a log to the base e. Okay, so log e of e is 1, log of 1 is 0. Now let's add it up, so we get 1 minus e by e, so we get minus c is equal to, now let's take this up, so e by 1 minus e. Now let's take this minus sign to the other side, and let's make that minus sign disappear by changing the signs of the denominator, so e minus 1. So what does this mean? I'm not talking of this particular problem, but Cauchy's mean value theorem, what does it mean? So if we draw a graph, right, and this is f of x and this is g of x, so the x-axis is not x, it is f of x. Y is not y, it is g of x. And if we have a graph like this is A, and let us say this is B, right? So A, B. So what Cauchy's mean value theorem says is the ratio of these 2 points, f of B minus f of A, the ratio of the difference between these 2 points. So g of B minus g of A is nothing but the ratio of the derivatives at some other point. So f prime of c is divided by g prime of c, or in other words, ratio of the difference between 2 points of these 2 functions is equal to the ratio of the derivatives of another point. So what this means is that there is going to be a tangent which is going to be parallel to AB, and there will be at least one tangent. There could be more than one tangent as well. So in case of this problem, that particular point is e by e minus 1. And if you really want to make sure, you have to check whether e by e minus 1 is between 1 and e, right? So 2.7 divided by 2.7 minus 1, which is 2.7 divided by 1.7, right? So this will be how much? If you do the division, it will be once 1 point. So just that much is telling you that it is between 1 and e, right? Okay, now let's take another problem. Let's say f of x is equal to x cube, g of x is equal to x square in the interval 1, 3. These are polynomials, so therefore they are continuous throughout. They are differentiable throughout for all values of x. But specifically in 1, 3, in the closed interval 1, 3, they are continuous and differentiable. Now let's see f prime of x is equal to 3x square. G of x is equal to g prime of x is equal to 2x, and g prime of x is not equal to 0 in the closed interval 1, 3. So by Cauchy's mean value theorem, there exists C being between A and B such that f prime of C by g prime of C is equal to f of B minus f of A by g of B minus g of, okay, let's do the substitutions. F prime of C is 3c square. G prime of C is 2c. F of B, that is 3, B is 3, so f of 3 minus f of 1 by g of 3 minus g of 1. So this 2 gets cancelled, so 3 by 2c is equal to f of 3 will be, f is x cube, so 3 cube 27 minus 1 cube 1. G cube is x square, g is x square, so 3 square is 9 minus 1. So c is equal to 27 minus 1, 26 by 9 minus 1, 8 times 2 by 3, which is equal to 2 fours, 2 twos, 2 13. So 13 by 6. Yes. So at C, the tangent would be parallel to AB. Okay. I think you got the idea. Bye for now.